The following is a QST.
You're listening to CQ Blind Hams.
Amateur radio from a non-visual perspective.
Hi everyone, this is Patrick N2DYI, and today I want to talk to you about how to optimize the received and transmitted audio quality of a Clearnode. After running the Blind Hams bridge for about 4.5 years at this point, it occurs to me that almost everyone who has a Sherry sounds better than almost anyone who has a Clearnode. For a while this puzzled me because the Clearnode and the Sherry both use the same radio module, the same sound fob, and mostly the same hardware. In fact, there's a Clearnode subscription you can get for the Sherry that basically turns it into a Clearnode, which I have. So why do they sound so different? Well, it turns out the explanation is pretty simple. They're just set up differently. If you follow the setup instructions for the Sherry, it tells you to do some very specific things with both the SA818 radio module itself and simple USB. And those things have not been done at all on a Clearnode. So in this podcast, I'll tell you what to change, how to change it, and why you should change it. I'll even include some audio examples of before and after, both in received and transmitted audio, so you can hear the difference. Although it's not quite as easy to demonstrate in a podcast. It will certainly be more noticeable when you hear the result on your own radio. Or maybe it would be better to say that others would notice the difference when they hear your radio on their radio. So let's cut to the chase. The nice RF SA818 radio that's used by the Clearnode, Sherry, and lots of other projects is not a particularly great radio. It has a horrible front end, it doesn't take much to trip the PL decoder, and the audio is, well, not the most optimal in the world. When I last priced these radios, they were about $10, so, you get what you get for a $10 radio. They're small, they're ubiquitous, but that doesn't make them awesome. Kind of like Bofeng HTs. They work, but they're not great. By default, the Clearnode uses essentially speaker and microphone audio from the SA818 to receive and transmit. This means that the audio is already filtered and de-emphasized, and it's honestly kind of muddy. My first All-Star node was based on a Motorola radio, so when I heard people using Clearnodes, I was honestly pretty underwhelmed because I had gotten used to some quite wider, nicer audio. Well, you certainly can't achieve Motorola quality with this radio, but you can certainly do better than the Clearnode's defaults. So what does it take to make this happen? Well, essentially inverting the emphasis curve. So what I'm going to do here, just so you don't have to listen to a long, rambly explanation and demo of stuff, is give you a TLDR and then come back and show you how it all works. Are you ready? I'm going to throw a bunch of numbers at you. Here we go. First, make sure you're not connected to any All-Star node before making any of these changes. In the Clearnode app, find the section that says Radio, Type, whatever your Clearnode model is, tap to configure. This will get you to the radio settings. On my iOS app, this is near the top center of the screen. Here, check the following three boxes: emphasis, high pass, and low pass. Also, just make sure the radio is set to wide, not narrow. Now tap Save. A confirmation will appear. Press Update. These changes can be applied without restarting the node. Now go to All-Star Setup. Find the switch that says Enable RX Notch Filter, switch it on, and change the frequency edit box to 297,50, 297,50. Tap Save. Allow your node to reboot. Once the node is back online, from the main screen of the Clearnode app, find the button that says Adjust USB Audio Gain for VoIP. Change the From VoIP Mix A set level to about 800 or so. Don't worry about changing the slider for TX Mix B set, it doesn't actually do anything on a Clearnode. Now change the 2 VoIP RX Mixer set level to 550. Change the TX DSP level from its default of 995 to 200. Now turn on the boxes for Enable De-emphasis and Enable Pre-emphasis. Now tap Save. Your node will need to reboot a second time. Once that's done, you should be back online with some nice audio in both directions. Okay, enough with the TLDR. Now I'll show you actually how to do all this stuff and why I made each of these specific changes. But first, let's talk about the audio that you hear from your node on whatever radio you happen to be using. As I've mentioned before, the radio's audio is not particularly broad. Here's a great example of that. I'm going to record a short piece of audio, which is this. The following is an audio test. This is N2DYI conducting an audio test. Now I'm going to take that audio and run it through some processing that I use for net control applications, which makes it sound like this. The following is an audio test. This is N2DYI conducting an audio test. So now let's take that audio and transmit it through my Alinco DR235T 220 radio and its connected All-Star node, and receive that through the discriminator tapped and de-emphasized audio on my Kenwood TMV71A. This should be basically a best-case scenario for pretty much how full things can sound, given the setup I have. The following is an audio test. This is N2DYI conducting an audio test. That could have been a little cleaner. There's some USB noise that sort of made some odd distortions happen. I need to put more ferrites on things, clearly, but you should get a pretty good idea about the frequency response anyway. Now here's that same audio transmitting across my Sherry turned into a Clearnode, coming across the same TMV71A, de-emphasized, and with the PL tone notched out. The following is an audio test. This is N2DYI conducting an audio test. So you may have noticed a couple of things about that audio clip. First of all, it's louder than the audio coming from the Alinco, and that's because of the DSP level on the node. The Clearnode has it at its default, and the Alinco has it turned way down. In this case, that also gives it some additional distortion, which isn't really desirable. And there's also a nice resonant right around 300 Hz. I'm going to do something a little bit terrible and use a bandpass filter to highlight this resonance that I'm talking about. On this audio clip, I'll just start the clip and then slowly fade into the bandpassed audio. The following is an audio test. This is N2DYI conducting an audio test. The following is an audio test. This is N2DYI conducting an audio test. The following is an audio test. This is N2DYI conducting an audio test. And this is the same resonant that lots of GD77s and Baofeng radios and various other cheap Chinese HTs all tend to have. The SA818, when in this particular mode, also has that resonant sound. So when you're listening to your Clearnode on a radio that already has that bump on it, it's going to stack. And when you're talking to somebody over a Clearnode who has one of those radios, it's going to stack even more. By the time you hear it, it may be 4, maybe 5, maybe even more of those resonant thingies deep. The good news, though, is when you flip the emphasis curve, it does clean up the transmitted audio as well as the received audio. Here's a clip from, actually, it's a different Sherry. I'm cheating a little bit here, but honestly, it's easier to go back and forth between the two. So this is the Sherry, not the Sherry pretending to be a Clearnode, transmitting that same clip with my optimizations, also coming through the TMV71A. The following is an audio test. This is N2DYI conducting an audio test. This clip, while it still has some noise, that's just a characteristic of the radio, does sound a little closer to the source, though not quite as full as the Alinco. This particular Sherry, unlike the one that's pretending to be a Clearnode right now, has the STE tone turned on, which is why you hear that at the end of the transmission. And yes, that really should be a sine wave, but clearly it's not because you can hear the fundamental and the third harmonic. So there. Fun fact, the Clearnode app doesn't let you change the state of the STE tone on the radio. That's a 59 Hz tone, by the way. For some reason, it's not enabled on my pseudo Clearnode, but I think most of them have it on by default. And you can turn it on and off if you manually program the radio, which I don't recommend if you're actually using a real Clearnode. Let's hear all three of those clips again, side by side, without me blabbing between them. First the Alinco, the Clearnode defaults, and then the optimized settings. The following is an audio test. This is N2DYI conducting an audio test. The following is an audio test. This is N2DYI conducting an audio test. The following is an audio test. This is N2DYI conducting an audio test. After the optimization, the isn't completely gone, but it is significantly reduced. So I'll take it. Now let's do a quick test between these two nodes using a Kenwood THD74, which honestly wouldn't be my first choice, but it was the first radio I grabbed, and it was the first radio that I could find that didn't have some weird difference between transmit audio on 2 meters and 440. I would much have preferred to use my THF6A, but it's much noisier on one band, and it would kind of screw up the test. this radio does have a little bit of its own resonant bump at 300 Hz. In this test, the volume of the two receivers is exactly as the node hears them. No processing of any kind has been done, which means that both the A and B tests will be significantly quieter than I am now. You have been warned. The first one has a bit of a 60 Hz hum in it. Whoops.
This is a Kenwood THD74 coming into the pseudo Clearnode with its default levels and filters and everything else. This is what that sounds like. Now I'm going to go to the other band on the radio, which is set up to go to the other node, which has my optimized settings. You should be able to tell the difference. And this is the same Kenwood THD74 coming into the other node with its settings, which are significantly different than the previous node I was on. You can probably tell there's more volume, there's a little more highs, and less distortion as well. N2DYI. Here's a Quanching UVK5 with an Anytone speaker mic connected to it coming into the optimized node. Now I'll switch over to the other one, and we'll see what the differences are with this particular radio. Well, this isn't really a particularly great test, because no matter where I go with this radio, this particular node sounds terrible. I can use other radios, and they don't sound terrible. Wow. Anyway, that's not quite what I was looking for.
You know, I really should have used the same node radio for all these tests, but the VHF node, which is pretending to be a Clearnode right now, is just noisy with certain radios. It doesn't matter where I am or where the node is, or if the node is on battery. It's very strange. But anyway, aside from that particular difference, the most obvious and striking one is the volume. The optimized node has more of it, but it also has more clarity in the highs, aside from all the other weird noises that the VHF node is making at the moment. But there's only so much you can do about that pesky little... I mean, it doesn't quite go away, but at least you can squish it. Okay, enough distractions. I did say several minutes ago that I would show you how to go through and configure all this stuff, so now I'm actually going to do that, about 8 minutes late. I have my iPhone here. I'm going to double tap on the Clearnode app in the app switcher, bring it up, and go to my node and set stuff up. So let's do that right now.
Clearnode, active. Clearnode, refresh, button.
So here's my list of nodes, which there's only one node in here, 508422.
Node, 508,422, 2024, 03, 232, 43, 508422, idle, button.
There we go. That first thing was a notification. So I'm going to double tap here. The node is not connected to anything, which is good.
Radio.
At the top sort of center of the screen, we have
Type S4B-818, tap to configure.
Type S4B-818. You will have a thing that looks a little different than mine. Mine is a Sherry Pi 4 hat, and it's a VHF model. So yours will certainly be something entirely different. So I'm going to double tap here to get to the radio settings.
TX rec.
I'm not going to change the TX or RX frequencies here. The only things I want to change are the emphasis, high pass, and low pass, and to make sure my volume is set to 6. So let's go through those.
147.5050, RX rec. 147.5, squelch type. Selected. CTCS, DCS. TX CTCS, decrement. But increment. But RX CTCS slash DCS, decrement. Button, increment. Squelch, 1-8, 2.
Squelch is at 2, that's fine, although 1 would be better.
Decrement.
But it really doesn't matter.
Increment. Volume, 1-8, 6.
And the volume is, in fact, at 6.
Decrement. Increment. Emphasis. Emphasis. Switch button. Off.
Alright, I'm going to turn emphasis on.
On. High pass. High pass. Switch button. Off.
I'm going to turn high pass on.
On. Low pass. Low pass. Switch button. Off.
And I'm going to turn low pass on.
Bandwidth.
And bandwidth should be set to wide.
Narrow. But selected. Wide.
It
button.
is. That's good. So I'm going to go back to the top of the screen and double tap on save.
Node details. Radio. Save. Button. Save. Alert. Update radio configuration. This may take several seconds. Do not interrupt power until you get confirmation the update is complete, or you will break the radio.
Oh no!
Update. Button.
Actually, you won't break the radio, I promise.
Node 508422.
And it should go and do its thing. Waiting. Woo, yeah, wait.
Alert.
Continue.
Message from Node.
There we go.
Node 508,422. Radio update successful. OK. Button.
Right.
Node 508422.
Once you've made these changes, go back to the radio configuration and make sure that those checkboxes actually did get checked. The first time I did this, it saved, everything looked okay, but the checkboxes weren't actually checked. Every other time after that, it was fine. At this point, if you were to use your node, the audio that you hear from it would sound incredibly muffled because it's being de-emphasized, and the audio that you send to it will be very, very bright and painful. So don't do that yet. Okay, the radio is configured, so now I'm going to go to All-Star Setup and change the RX notch filter options. I think in my case I've already set the frequency, but the filter is disabled, so let's see.
Node 508422. MAC address DC A632C.
Okay, I'm going to just go through all these until I eventually find the All-Star Setup.
LAN address. Wi-Fi SSID. Last connect. Last disconnect. Hardware ID of CPU. Last connection. WAN address. Last startup. Versions. Red Node API. All-Star control. Digital bridge controller. Asterisk 1.n/a. Red Node coder. Node setup. All-Star setup. Button.
There we go. All-Star Setup.
Cancel. Button.
Now, like I said, the only thing I need to change here is the Enable RX Notch Filter option and make sure the frequency is right.
Setup from node. Heading. Menu. Button. Save. Button. Red Node interface. Retry network. N4. Text. Enable automatic red node up. Enable automatic red node up. All-Star identity. Node number. 508422. Text. Node password. Switch/Zoiper password. All-Star server. IX port. 9 port. 456. Enable IX from network. Enable IX from net. Transmit timeout. 999. Receive timeout. 16000. Hang time. MS. 100. Text. Alt hang time. 100. Enable RX notch. Enable RX notch filter. Switch button. Off.
Turning that on.
On. RX notch filter. 297. 50,297. 50. Text field.
The frequency is already set up because I changed this once before, so just reviewing if I go
Edit.
here.
Characters. 297, 50, 297, 50.
Perfect. 297, 50, 297, 50.
Use voice ID. Use voice ID. Switch button. Off.
That's fine. That's great. So now I'm just going to press save,
Cancel. Setup from menu. Button. Save. Button.
which will cause my node to reboot.
Save. Alert. Node setup. Important. This operation will recreate the node configuration files from templates. Overriding any existing configuration. Conf. Files and any custom changes you have made by SSH or Supermon. Send setup and restart node. Button.
Yeah, do that. Okay.
Let's start nodes.
Now, when the node comes back online, you'll hear it give its IP address, and it'll sound very muffled coming back through my Quanching UVK5. And this will eventually be fixed when we go in and change the appropriate settings in the simple USB configuration.
IP address
Oh,
192.168.1.3.
I did mention that would sound pretty bad. Okay, now the node is back online, so let's fix those audio settings in simple USB.
508422. Idle. Button.
Double tap here,
Radio.
and let's go to configure. What is it? Configure USB gain for VoIP or something?
MAC address. DC A6.
I'm not really a Clearnode person. I'm still getting used to this app.
LAN address. Wi-Fi SSI. Last connect. Last disconnect. Hardware ID. CPU. Last connect. WAN address. Last startup. Versions. Red Node API. All-Star control. Digital bridge. Asterisk 1.4.n/a. But Red Node code revision. Node setup. All-Star setup. But Echo Link setup. But Digital bridge setup. Button. Adjust USB audio gain for VoIP. Button.
There it is. Adjust USB audio gain for VoIP.
Simple USB audio tuning.
Okay, here there are a bunch of levels to change. The first one is this one.
From VoIP. Mixes it. 450.
From VoIP TX Mix A set, I want to turn that way up to 800. It's currently at 450. So let's turn that up to 800. Unfortunately, the only way I know to do this is to continuously double tap on the increment and decrement buttons, which takes forever.
Increment. Button.
It's at 450 now, so if I press it once,
Increment.
now it's going to be at what, 460, I
Decrement.
think?
From VoIP. Mixes it. 460.
Yeah. Oh boy, we're going to be here for a while.
Decrement. Increment. Button. Increment. Increment.
Increment,
Increment.
increment,
Increment.
increment,
Increment.
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 2,000 years later.
Okay, finally got it to 800.
From VoIP. Mixes it. 800.
Perfect. That took way too long, but such is life. All right, now, TX Mix B set, I'm not going to bother with because it doesn't really do anything.
Increment. From VoIP. Mixed it. 430. Decrement. Button. Increment. The VoIP. Mixers it. 450.
The 2 VoIP RX mixer set, I want to change to 550. The increment and decrement buttons go in values of 10, which means I have to press it 10 times. Oh boy, here we go.
Decrement. Increment. Button.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Decrement. The VoIP. Mixers it. 550.
Now this next one is going to be real fun.
Decrement. Increment. TXDSP. TXDSP LVL. 995.
Okay, this is at 995, and I want it at 200. This is going to take forever.
Decrement. Button.
All right, here we go. In values of
Decrement.
10, 985, 975, 965, 55, 45, 35, 25.
Later that same evening.
Actually, 205 is as close as I'll be able to get to 200, but that's okay.
Decrement. 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 TXDSP. TXDSP-LVL. 205.
And I'm finally there. Oh man, that took way too long. All right.
Decrement. Increment. Carrier from.
Next, we're going to change the emphasis options, both of them.
No. Us. But selected. CTCSS from. Selected. Us. Invert. Button. Invert PTT. Invert PTT. Enable PL filter. Switch button. On. Enable DCS filter. Enable DCS filter. Enable de-emphasis.
There we go.
Enable de-emphasis. Switch button. Off.
Let's turn de-emphasis on.
On. Enable pre-emphasis. Enable pre-emphasis. Switch button. Off.
And turn pre-emphasis on.
RX audio delay. 10.
And I'm not going to mess with anything else here. Let's press save, make the node reboot a second time. By the way, on a normal HamVoIP node, you can do all this stuff with no reboots. I don't know why this thing reboots so much.
Node details. USB audio. Show.
Oh
Button.
well.
Save. Button. Save. Alert. Save audio setup. This operation will rewrite the simplest underscore tune underscore us. Conf file under send audio setup and reboot node. Button.
All right.
No
Do the
refresh.
thing.
Button.
And eventually we will hear the node announce its IP address again. And except for some radio noise and the fact that I'm using a not so awesome radio, it should sound significantly better. Let's see.
IP address 192.168.1.3.
And there we go. Setup should be complete. So let's do a couple of tests just to make sure it is in fact doing what it's supposed to do.
Node 55553 connected to N2DYI.
This is N2DYI testing with the fake Clearnode and the Kenwood THF6A. Good evening, hello, and junk. Audio level is just about right. This is N2DYI testing with the fake Clearnode and the Kenwood THF6A. Good evening, hello, and junk.
Cool. Looks like I did everything right.
Here's some audio from the Kenwood THF6A as heard directly from the fake Clearnode without another radio in the way, so you can hear exactly what the processing does to this radio. For an unfair comparison, here's the THF6A being received by the TMV71A's discriminator output. Yes, sounds significantly smoother, but hey, this isn't an SA818 radio. So there's that.
You're probably not asking yourself why I made some of these changes, but I'll tell you anyway. In HamVoIP, the DSP level is actually designed to overcompensate for things with low audio. It does this by essentially squishing and limiting things once a certain threshold is reached. With really hot audio, not only can this cause distortion and clipping and all sorts of other bad things, but it can also screw up the CTCSS decoder on some radios. Here's a great example of that. This is my Quanching UVK5 receiving my Clearnode with its default settings as I connect to my parent node.
Node 55553 to N2DYI.
This is with the CTCSS decoder off, the bandwidth set to wide, and the squelch set to 1. In other words, it's almost all the way open, but not quite. So I basically did everything the radio could possibly ask me to do to sort of make things better on the radio side, but the DSP level being really hot just squished things very loudly. So after turning it down, it sounds like this.
Node 55553 connected to N2DYI.
Hopefully, though, yours won't have a bunch of background noise like mine does. That's what I get for trying to use a VHF node in a noisy environment, and I think there's actually a problem with my SMA connector. Anyway, once you've turned down the DSP level, things will be very quiet unless you turn the transmit level up. That's why I changed it from 450 to 800. As far as the input level goes, what I like to do is go to my parent node, speak loudly and clearly into the microphone of a radio, whichever radio I'm using, until it gets to the point where it says I'm a little above average, and then I'll back off slightly to the point where it says audio level is normal, and then I know I have things pretty close. With most of the radios I have here, after doing all the emphasis changing and all that stuff, I found that the value of 550 is pretty good. You may want more or less gain depending on which radios you use, but I think 550 is pretty good. So why do all this emphasis stuff? Well, basically, when you do that, you're setting the node up as if it's a radio that has a discriminator output, which, by the way, it doesn't. It sure would be nice if it did. But it does put the radio into a mode where it's no longer sending speaker audio and receiving microphone audio. It's not flat, but it's closer to flat. So by emphasizing the radio, then applying pre- and de-emphasis in the simple USB configuration, you're essentially changing the entire curve of the radio and the audio characteristics in what I think is a better application of that radio's hardware. Basically, all this is a compromise, and it's pretty much the best compromise I can come up with to make the Clearnode audio sound, well, clearer than it does out of the box. I definitely encourage any of you who have Clearnodes to make these changes, because if nothing else, it will definitely clean up what we hear from your node. And what you hear from us sound a little better, or maybe even a lot better, depending on which radio you use. That's pretty much all I have on the topic. Thanks for listening, and 7-3.
OMG Industrial presents DYI Digify. Have you ever thought to yourself, this music just sounds way too nice? If so, we've got the thing for you. It's DYI Digify, bringing the warm sound of DMR to any audio you like. Whether it's radio communications, music, podcasts, audiobooks, boring training material from work, you name it, we maim it. But wait, there's more. OMG Industrial's patent-pending dual time-slot processing makes use of Moto Turbo's dual time-slot functionality to provide stereo DMR. That's right, stereo DMR. Time slot 1 on the left and time slot 2 on the right. No longer must you be restricted to single-channel communications audio. Experience the full immersive sound of DMR in stereo. For more information, visit our website at www.com.